As the world transitions to green energy, we are seeing more and more electric vehicles on our roads, and the demand for clean energy storage is growing significantly. And there's one component in all of these that is absolutely crucial, and that is batteries. Have you ever wondered how those batteries are made? Well, today, come with me and we're going to find out. Today, we're at CATL. Who are CATL? CATL are the largest and most innovative battery manufacturer in the world. They have 13 factories, 11 in China, 1 in Germany and 1 in Hungary. They have a global market share in EV batteries of 36.8%. There's a good chance that if you own an EV, it may have CATL batteries in it.
CATL have their batteries in over 12 million vehicles and over 60 countries worldwide.
As you can see, CATL have won numerous awards, and one award of particular significance is won by the chairman, Robin Zhang, and he's won the Lifetime Achievement Award for Advanced Technology Batteries. And this was awarded to him because he's managed with his company to actually mass produce this battery technology at large scale, which is indeed very difficult. Sometimes it's, you can create technology in the lab, but moving it to mass production is much more difficult, and that's what Robin has achieved. Okay, so put this armband on. I have no idea what that says. And I've got a master put on, which I'm going to put on in a minute, so I'm all ready to go. Okay, so we're all clear. And we're in the factory. Wow. Right, so we're deep in the heart of where the battery process starts. And all these tanks behind me are where the chemicals are mixed. These chemicals are mixed into what they call like a slurry. It's like a paste. And what then will happen, they will be applied to the anode and cathode material. But yeah, there's a lot going on, there's a lot of mixing. This chemical mix is now like a paste, and it will be applied to the anode and cathode material, and that will be copper and aluminium. And as you can see, it's going through this machine, it's putting a coat on there. Now this material that it's been applied to is extremely thin. It's about the 10th of the thickness of a human hair, so it's very, very thin. And it has to be coated on both sides, so it will first go through this machine, and it'll come back around and it will be coated on the other side. Once it comes off that machine we just saw, it comes here, and these rolls are 3,000 meters long, 3 kilometers long. That's quite amazing. And they have this chemical now which is coated on to both sides, and this is the cathode and this is aluminium, and the anode will be very similar, but it will be on copper material. And once that is done and dry, they're stored here, and they will then go on to the next part of the process. So this next process here is called calendaring, and actually it prepares it goes through here to a large machine there which we're not allowed to film. But what basically that does, it actually, once the chemical's on the aluminium material, it makes it even thinner, so it kind of compresses it to make it even thinner still, and then it's rewound back onto the roll and it goes on to the next process. CATL are a world leader in battery innovation, and this is demonstrated by their commitment to research and development. In 2023 alone, they spent almost $3 billion in R&D. They have a department of over 20,000 people, and more than 350 of those are PhDs. What I have here, this is the future of battery technology. This is CATL's cutting edge product, and it can deliver 500 watt hours per kilogram. And this is the kind of battery that will be used in electric aeroplanes of the future. And this is happening now here at CATL.
So what's happening in this machine here is the roll is being split into two, and it's also having its terminals attached.
to the material. So those are actually ultimately the battery connections, what you discharge and charge the battery through. The machine winds both the anode and the cathode together, and this is what you end up with. You end up with this, and this is basically the inside of the battery. This is the terminals where the battery is charged and discharged from, and this is called a jelly roll. That's very, very interesting. It just seems too simple to be a battery, but this is the inside of the battery cell. And this is the area where they do some manual inspection when they're coming out the machines. They come along here and they inspect these jelly rolls. This machine is basically compressing the jelly roll. So they heat it up, and then it's put under pressure to be compressed into a more sort of solid shape, and that forms the internal part of the battery. So basically, once it's come through that process, each cell needs 2 of the jelly rolls. So what that machine does, it puts the 2 together, it puts this end cap on, and these will be your terminals for your battery. So the 2 jelly rolls are then encased in this container, and there's a little hole here in the top, just there, and that allows for the electrolyte to be put in. I guess that will be the next stage. So one of CATL's leading market products is the Shenxing battery, and this is the original Shenxing battery, which was released in August 2023, and this has a range of over 700 kilometers, and it can charge to 400 kilometers in just 10 minutes. However, at the recent Auto China 2024 exhibition in Beijing, which was just a couple of weeks ago, they released their Shenxing Plus, which can now do over 1,000 kilometers and can charge 600 kilometers in just 10 minutes. And I think it's amazing how quickly that they have moved that battery technology. Just in the space of 9 months, they've increased that range by 300 kilometers and the charging in 10 minutes by 200 kilometers. That is really, really some innovation. So the area we're in now is the baking area, and what that means is that the cells, before they have the electrolyte put in, they need to make sure there's no moisture inside. So they go into some kind of large ovens and they're baked, and that makes sure there's no moisture left inside the battery cell. Once they've been baked, they're going to go on to have the electrolyte put in. So once the battery's added, electrolyte added, it goes into a number of tests. Unfortunately, we are not able to show you that testing. It goes into a number of tests, it's charged and discharged. It takes about 3 or 4 days to do all the tests, and then this is what we end up with. Now, this is a safety measure, so because they are live, and this is what a finished cell looks like. And this is, you can see how it's packaged here, and then these basically go off to the customer, or they go to put into larger packs and then straight into your car. So we're now going to show you some of CATL's technology in action. The Zeekr 001 behind me contains CATL's Qilin battery, and this can charge very, very quickly. We're going to show you on a 600 kilowatt charger just how fast these batteries can charge. You take the charging cable, and it's as easy as that. Just like filling a car with fuel, but this time it's electric fuel, not fossil fuel, which is fantastic for the environment. So you have LFP batteries here that are used in commercial vehicles. You have some here, these are used in electric vehicles. This is a standard NCM cell, and then you have LFP cells here that are used in energy storage solutions. You have these smaller ones here which are used in hybrid vehicles. But this here, this is really, really interesting. This is something I've learned new today, that if you have an electric car and the battery, the large battery that drives the motors and propels the vehicle along, they don't actually use the same battery for the ancillary things within the vehicle, like the air conditioning, the computers, etc., the navigation. It will be a separate battery, and this is one such separate battery. It's made up of a number of these smaller cells here, and yeah, that's something I didn't aware, and apparently CATL have supplied many millions of these into the market for EVs. So behind me is battery energy storage solution, and currently this is around 20% of CATL's overall business, but they see this as a very much a growth area. And what this is, when you generate power by wind turbines or by solar, not necessarily is that power needed at the time it's generated. So maybe it's solar in the daytime, you're generating a lot of electricity from solar, but actually the energy usage on the grid is not so high in the daytime, it's higher in the evening time when people are at home. So what these solutions allow you to do is, when the energy is generated by the solar power, it will go into these large battery storage solutions, and it will then be fed into the grid at the time that the grid needs that higher demand, in maybe the evening time or the night time when many people are at home cooking, watching TV, etc. And this is a full-size rack, so this will have numerous battery packs. Each of these packs will contain a number of cells. And then here we have, this is a model of a 20-foot container, and there's 5 racks of storage in there, and these will, as I say, when the power comes from the wind turbines or the solar panels, it will be stored in these batteries. And then many of these can be linked together, and they will have like software and systems that control them, so that they can then control the energy in and out of these storage solutions. But with so many batteries being produced, are we creating a future problem of millions upon millions of old disused batteries? At CATL, they have prioritised recycling in their battery design process, establishing a comprehensive circular ecosystem. Through their subsidiary Brump, they employ directional recycling technology, extracting valuable metals like lithium, nickel, cobalt and manganese, which are then used in the production of new batteries, creating a sustainable mineral supply chain. Currently, CATL are able to process 120,000 tonnes of waste batteries annually, with plans to expand this to 1 million tonnes. They have 7 recycling bases worldwide and have achieved significant advancements in recycling technology, with over 4,500 patent applications related to battery recycling tech, with recovery rates of 99.6% for nickel, cobalt and manganese, and 91% for lithium. CATL has contributed to the development of 369 industry standards. Currently, CATL's comprehensive recycling rate for waste batteries is 50.4% domestically and 34.4% globally. Something that CATL have developed, they've not only developed products for EVs and new energy storage. What they have developed, they've developed a whole range of commercial batteries. So commercial batteries sometimes need to work in harsher environments. So for instance, in China, you might go to Heilongjiang province and the temperatures drop to sort of -35, -40. And then in other areas of China, you can have temperatures of +35. And they've developed a number of commercial batteries to be able to work in all those scenarios. And that's really commendable. You know, they have various different solutions, so they work very closely with their customers to develop solutions for that customer need, and that's very important from a battery company. So I hope you liked that video of this factory tour, and I hope it's give you a little bit more understanding of CATL as a company. If you did like this video, please hit that thumbs up button. If you like the channel in general, consider hitting that subscribe button. However, from Ningde here in Fujian province, as always, for now, take care.